In this pencast, we're going to be learning about operations with complex numbers. The first problem says, let z equal 7 minus 4i and w equal 10 plus 3i. Find z plus w and z times w and simplify. Alright, so let's start out with z plus w. That's going to be the same as saying 7 minus 4i plus 10 plus 3i. Alright, so in order to do this, what we're going to do is we're going to add the real parts and add the imaginary parts. So the 7 and the 10, those are the real parts. And then minus 4i and 3i, those are imaginary. So we're going to add the real parts together. So that's going to be 7 plus 10. And then we're going to add the imaginary parts together, which is minus 4i plus 3i. Alright. So when we simplify that, what we should get is 17 minus I. So that's the answer to z plus w. Alright, so now we need to do z times w. So that's the same as 7 minus 4i times 10 plus 3i. Alright, so in order to do this, we're going to use FOIL. And in case you don't remember, FOIL stands for first, outside, inside, last. And that is just the order that we're going to multiply the terms in. So first we're going to multiply the first term in each parenthesis. So that's going to be 7 times 10. And then we're going to multiply the outside terms. So those are going to be 7 and 3i. Then we're going to multiply the inside terms. So negative 4i and 10. And then the last term in each parenthesis. So negative 4i and 3i. Alright, so now we just need to simplify that. So 7 times 10 is 70. 7 times 3i is 21i. Negative 4i times 10 is negative 40i. And then negative 4i times 3i is going to be negative 12i squared. Alright, now the thing we need to remember is that I squared is equal to negative 1, so that's the definition of the complex number. So now we should be able to simplify that even further to 70, and then 21 and 21i and minus 40i, we can combine those terms to give us minus 19i. And then we have minus 12 times negative 1, since I squared is equal to negative 1. So that gives us 70 minus 19i plus 12, which is 82 minus 19i. And that's the answer to part 1. Part 2 says, let z equal 12 plus 6i and w equal 1 plus I. Find z minus w and z divided by w and simplify. Alright, so let's start with z minus w. So that's going to be 12 plus 6i minus 1 plus I. Alright, so now what we want to do is subtract the real parts and subtract the imaginary parts. So the real parts are going to be 12 minus 1. That's the real part. And then the imaginary parts are 6i minus I. So when we simplify that, we're going to get 12 minus 1 is 11, and 6 minus I is 6i minus I is 5i. So we get 11 plus 5i. So now we want to do z divided by w. So that's going to be 12 plus 6i over 1 plus I. Alright, So the first thing we want to do is try to simplify this. So this is sort of similar to simplifying when you have square roots in your problem. You don't want any square roots on the bottom. Well, we don't want any imaginary numbers on the bottom. So in order to get rid of this imaginary number on the bottom, we're going to multiply by the complex conjugate, which is going to be 1 minus I. So we're going to multiply by 1 minus I over 1 minus I. So once we do that, we're going to FOIL out the top and the bottom. So we're going to get 12 minus 12I, let's see here, plus 6I, and then minus 6I times I. Alright, and then on the bottom, we are going to get 1 plus I minus I squared. Alright, so again, let's keep in mind that I squared is equal to negative 1 because of the definition of complex numbers. And let's try to simplify this down a little further. Alright, so if we combine like terms on top, we're going to get 12 minus 6I squared. And then on the bottom, we're going to get, if we combine like terms, those i's are going to cancel out in the middle, so we're going to get 1 minus I squared. Alright, so now let's substitute in negative 1 for I squared. So we'll get 12 minus 6I minus 6 times negative 1. All of that over 1 minus negative 1. Alright, and when we simplify that even further, we're going to get, so this is going to turn into 12 minus 6I plus 6 over 2. That's equal to 18 minus 6I over 2. Alright, and we should be able to take a 2 out of everything here. So if we factor a 2 out of everything, we're going to get 9 minus 3I, which is our final answer. The third part of this problem says, find the value of a plus bi times a minus bi. Use that to find the value of 2 plus square root of 3i times 2 minus the square root of 3i. Alright, so let's start by finding the value of a plus bi times a minus bi. So we're going to FOIL this out. So we're going to do first. So the first term in each parenthesis is a. So we're going to have a times a. Then we're going to have the outside terms. So that's going to be a times negative bi. The inside terms are going to be bi times a. And then the last terms are going to be bi and negative bi. Alright, so when we simplify that, we get a squared, and then we can see that this a minus bi and this a bi are going to cancel out. So then we're just left with plus b squared I squared. Sorry, that should be minus b squared I squared. Alright, so now we know that I squared is equal to negative 1. So this simplifies to a squared minus b squared times negative 1. And that is the same as a squared plus b squared. Alright, so if we follow this pattern, we should be able to solve 2 plus the square root of 3i and 2 minus the square root of 3i. Alright, so our a in this problem is going to be 2, and our b in this problem is going to be the square root of 3. So what we want to find is a squared plus b squared, since we know that that's what this is going to simplify to. So that's going to be the same as 2 squared plus the square root of 3 squared. Alright, so we know that 2 squared is 4, and we know that the square root of 3 squared is just 3. So we're going to end up with 4 plus 3, which is going to give us 7. And that is the answer.